right? So sometimes you may get question to calculate the isoelectric point for this given amino acid. So I am giving you, a concept and shortcut how to calculate the isoelectric point. This is very important question. This, many times the questions are asked like this. So calculation of isoelectric point, right? So for calculating any, isoelectric point for any alpha amino acid, you have to, know the value of pKa1 and pKa2. So what you can do? First step, you take fully protonated, fully protonated, protonated form of amino acid. Fully protonated form of amino acid. So suppose that I am taking an example of alanine. So what is the formula of alanine? Alanine has the formula CH3CHNH2 COOH, right? So what is the fully protonated form of this? This is the formula, and its fully protonated form is this: CH3 CH NH3 plus and COH. C fully protonated form is this. See, one proton is here and one proton is here. So this is fully protonated form. Fully protonated. Suppose that if you have amino acid in which two NH2 groups are there, so you have to take all the NH2 group in the protonic form. So this is the fully protonated form of alanine, right? And this COH group, this has pKa1 value, means negative log of Ka is 2.34. 2.34. This should be given, otherwise you cannot calculate. And pKa2 for this proton, NH3 plus proton, this H plus from here, the Ka2 is 9.69. 9.69, right? So what you can do, if you have this value pKa1, pKa2, sometimes 3 4 acidic basic groups are there, so you have to take all those in a fully protonated form. So you have pK1. Actually, this is a method of calculation. This is a method of calculation basically. So take the fully protonated form and now start titrating this with NaOH. So means there is no need to bring the test tube and burette and pipette and try to this titrate, but you can assume yourself that I am titrating with the NaOH. So if you are adding drop by drop NaOH, what will happen? This proton first release or this proton first release? Obviously, this is more acidic. pKa1 is less, so this is more acidic, and this is less acidic proton, less acidic proton. So what will happen when you are adding drop by drop this NaOH to this solution? This proton will go, and finally you will get CH3 CH COO minus and NH3 plus, right? This is a Jupiter ion. This you will get 100% at the end of the first end point, because here two protons are there, so you will get two end points. So this is first end point, after first end point, after first end point. Clear to everybody? Okay. So after first endpoint, we have this 100% Jupiter, right? Now, if you keep on adding NaOH in this, then what will happen? Keep on adding NaOH. So now this proton will go, and finally you will get CH3, CH, NH2, COO minus. This is anion. This is cation, and this is Jupiter ion. So here pKa1 is used, and here pKa2 is used. Means second proton is used. Clear? So what is Pi for this? If you want to calculate, so what you have to see in different cases, you have to your focus should be on the Jupiter ion. So you have to take pKa value one step before the formation of Jupiter ion and one step after the formation of Jupiter ion. So before and after, I take the average of that. So Pi is equal to, in this case, is equal to pKa1 plus pKa2 by 2. So average of these two is the Pi, means isoelectric point. So pKa1 is 2.34 plus 9.69 divided by 2. So this is right. So this is the Pi, means at this pH your alanine molecule exists 100% in this form, and this will not migrate either side of the electrode. Clear? Clear to everybody? Okay, good. So what you have to do, one step before and one step after. Now I am taking another example, right? I am taking another example, and this time suppose that this amino acid is given 1, 2, 3, 1, 2, 3, and NH2, right? Suppose that this alpha amino acid is given in which two amino groups are there, right? So what first requirement? Take the fully protonated form. So fully protonated form of this NH3 plus. So this is fully protonated form. Fully protonated form. Now identify pKa1. Most acidic is this. pKa1 is this. pKa2 is this. And pKa3 is this. Right? This is pKa3. Okay, good. Clear? Now start adding NaOH. So which proton will lose first? This proton will go first. So pKa1 is used here. So what you are getting here? So after first endpoint, you will get this ion. Now tell me, is it Jupiter ion? Is it Jupiter ion? The answer is no. No. No positive, I mean positive negative. right? Complete positive negative. So this is not a Jupiter ion. This is a cation, no Jupiter ion. Jupiter ion. This is net cation. Net, it is cation. Jupiter ion means neutral. Positive and negative equal. Positive and negative equal. Right? Means if we are, telling that okay, this molecule is neutral. Means this molecule is neutral means it has two meaning. Means naturally there is no charge, or it has equal positive and negative charge. So Jupiter ion basically neutral ion having equal positive and negative charges. So this is not a Jupiter ion, right? Now keep on adding NaOH. Put NaOH and identify the second endpoint. This time this hydrogen will go, means pKa2 is used here. So after the second endpoint, what do you get? Now see, this is Jupiter ion. This is one negative, one positive, overall neutral. So this is Jupiter ion. Jupiter ion, right? Now see, this pKa2 is important for us in the calculation of, because what I have given you the shortcut that you take one step before the formation of Jupiter ion and one step after the formation of Jupiter ion. So now come to the next step. Keep on adding the NaOH. Keep on adding the NaOH. So what will happen? This time this will go pKa3 and you will get so this is anion, not a Jupiter ion. So one step before, this is a Jupiter ion. This is an important ion for us. This is a Jupiter ion. So this is a Jupiter ion. One step before and one step after. So now Pi for this is equal to pKa2 plus pKa3 by 2. So the average of this is called Pi, isoelectric point. So pKa1, pKa2 and pKa3 are given. So you have to take the average of pKa2, pKa3, not pKa1, pKa2, not pKa1, pKa3. You have to take pKa2 and pKa3. So similarly, if the question is given like this, you can very easily calculate the isoelectric point for given amino acid, right? So such type of problems you may get in your exam. Suppose that one question is given. Suppose that a question is given like this. COH group is there, NH3 plus group is there, and SS. This is also alpha amino acid fully protonated form. pKa for this is 1.8 is given, and for this pKa is equal to 8.3, and for this pKa is equal to 10.8. And the question is asked that draw the dominant structure of this molecule at pH is equal to 1, at pH is equal to 5, at pH is equal to 9, and at pH is equal to 12. So basically you have to draw the structure of this at different pH. Dominant structure means which one is more, not exactly going to calculate the percentage of how much is there. So for such type of questions, first you have to identify or calculate the PI. So how to answer such type of question? First, calculate the PI, isoelectric point. So imagine which pKa we are going to use to calculate this, right? See, first when you start titrating, this is a fully protonated form. When you put this NaOH here, so first proton this will go. When this will go, you will have negative and positive, means you will get Jupiter ion. So after first endpoint, you are getting Jupiter ion, so you have to consider this in the calculation of PI. Keep on adding, keep on adding. So this second time this proton will go. So this, when this proton will go, so you will get after second endpoint this negative and single positive, means net anion. So what concept I have given you, before one step of the formation of Jupiter ion and after immediate step of the formation of Jupiter ion. So after Jupiter ion, this pKa is used. So what is Pi for this? The Pi is equal to 1.8 plus 8.3 by 2, average of these two, right? So 11 and this is 10 by 2, so this is 5.0, right? 5.0. So Pi is 5. Okay. So here the question is asked, draw the dominant structure at pH is equal to 1, 5, 9 and 12. So what will happen? So see the answer at pH 1. At pH 1, right? What will happen? At pH 1, this is less than this, I mean, isoionic point, right? 5.05, this is less than. So the predominant structure at pH 1 is what? At pH 1, the predominant structure is the, same as given to you, COOH, NH3 plus and SH. This is the predominant structure at pH 1. There is no change, much change, right? Now at pH 5, at pH 5, you know this will Pi, so at this you have Jupiter ion, so the predominant structure at this pH is COO negative, NH3 plus and SH. So this is at pH 5. At pH 9, see at pH 9 how to increase this pH? By adding NaOH, means base. So at pH 9, so pH 9, this proton will go. So the predominant structure, but not we cannot say that 100% this will go, but major component is this S minus. This is the major structure at this pH, right? And now the other is pH 12. So pH at pH 12, see this proton also eliminates, dissociate. So you will have this is the prominent structure at this pH. So this type of question may be asked to you, that draw the predominant structure at different pH for the given amino acid. Now one homework for you, all of you can do yourself. I am giving you one amino acid. CH NH3 plus COOH CH2 whole 4 and NH3 plus pKa is equal to 2.18, 8.95 and 10.79, 10.79, right? So draw the structure. Same question. Draw the dominant structure. Dominant structure. Structure at number 1. pH is equal to 1. Strongly acidic medium. Number 2. pH is equal to 2.18. Number 3. pH is equal to 9.87. And number 4. pH is equal to 30. Right? So draw the prominent structure and also find Pi. Find Pi. Right? So solve this problem. Right? And let me know how to calculate this PI and different structures, right? Okay. See, test for alpha amino acid, test for test for alpha amino acids. See, this is very I mean important test known as nin hydrin test. Nin hydrin test shown by all alpha amino acids. And actually, this ninhydrin is a compound, organic compound, not the name of any scientist. See, this is a ninhydrin. This is ninhydrin. 2 moles of this. Uh, when you spray this ninhydrin on this alpha amino acid, so basically alpha amino acid reacts with this in any way, whether you are spraying this or you are directly reacting this, right? Or CH2COH. So you will get, I mean, compound, organic compound, a kind of dye, colored, right? Colored dye. Here, N double bond. This is the second molecule. Double bond O, double bond O, and oxygen will lose from here and double bond will come here, O minus and double bond O. So this is a violet color compound formed. Violet color. Violet color. Right? And RCHO plus CO2 plus H2. These are the side products, right? So this violet color, formation of this violet color compound, this is the, I mean, proof for this presence of alpha amino acid, right? Now see, test for polypeptide, test for polypeptide or protein or amide, because all have polypeptide, protein or amide, means polypeptide and protein all have this amide linkage. So for this I have already discussed, but again you can see biuret test. Biuret test. This is also the name of the compound. So see this NH2 urea also gives this test, NH2CO, NH2 plus NH2CO, NH2, 2 moles of this. When the urea is heated, basically, so we will get a compound NH2CO, NHCO, NH2. So basically, an amide linkage is there. See, this is a amide linkage, amide, and similar linkage. And this compound is known as biuret. Ammonia is eliminated from here, and this compound is known as biuret. Right? Similar bonding is there in polypeptides and in proteins. So if you take polypeptide chain, so you will have this type of bonding, right? C double bond O and H. So basically, this is polypeptide chain. So this is the amide linkage here. So protein and polypeptides all have this amide linkage like this biuret. So the same test you can get from this also. So this biuret basically this will give I mean if you take copper sulfate and NaOH, alkaline copper sulfate, so you will get red oblique pink color, right? So this is called biuret test. So any compound having this amide linkage, that will give this test positive, known as biuret test, right? And see, alpha amino acids, they condensed in a very specific and very particular, I mean, condensed in a particular manner, particular manner, and produces polypeptide, and if this a certain number, this if exceed, then this is called protein. So basically the molecular on the basis of molecular mass, so protein has molecular mass, basically this classification is based on the molecular mass. So 10 to the power 4, more than 10 to the power 4, then this is protein. And if molar mass is less than 10 to the power 4, so this is polypeptide, right? Now, see, we can say proteins are macromolecules. Proteins are macromolecules. Macromolecules, right? And as well as you can say and polymer. Polymer. Which type of polymer? Condensation polymers. Condensation polymers. Condensation polymers, right? So all macromolecules are polymers, but all polymers are not macromolecules. So what is the difference between macromolecule? See this and difference between this. Sometimes I mean this single unit. I mean molecule we have that is a high molecular weight compound. So that like chlorophyll, hemoglobin. So they are macromolecules, but they are not polymers. But because there is no repeating units for polymers, repeating units should be there. So here the repeating unit is alpha amino acid. So they are macromolecules and polymers. So both the definition they I mean fulfill, right? Okay. Now see structure of protein. This is structure of protein. So proteins basically are very large molecules, high molecular weight compounds. So protein has four different structures. First structure is known as primary structure. So primary structure basically this tells about the sequence, tells about the sequence of amino acids like GLY, ALA, alanine, arginine, valine, right? Like that. Means in the primary structure we study how this I mean peptide or protein is made up of with the different amino acids. What is the sequence? Means after glycine, alanine is there, arginine is there, like that. This tells about this is very primary structure. So this is the primary structure which tells about the sequence. Means after which amino acid, extreme left which amino acid is there, and extreme right which amino acid is there. So this will tells about the I mean uh, particular sequence of amino acid. Now come to the second is secondary structure. Secondary structure. So secondary structure tells about the backbone of the protein. Tells about the backbone of protein. Right? And this backbone consists two part is one is beta plated structure and other one is alpha helix. So basically, this backbone means secondary structure have beta plated as well as alpha helix. And which type of forces are there? Here, hydrogen bonding is there. See, this is the additional forces. Here in primary structure, there is no talk about the additional secondary forces. Here only the covalent bonding is there, that is polypeptide bonding, right? So hydrogen bonding and dipole-dipole interaction. Dipole-dipole, right? So see beta plated structure. This structure is like this. C double bond O here N H R H C double bond O N H and So see, there is a hydrogen bonding between these two and like this. So this is plated structure, beta plated structure, and alpha helix. This type of folding is there. So these folds were, bonded with hydrogen bond, C double bond O. There is a hydrogen bonding. See here, hydrogen bonding. So they are, bonded with means CO and NH group are folded like that, that they will form the hydrogen bond. So this is the secondary structure of this what proteins. And one very interesting fact we have here, if you see this carbon is sp3, this is a planar structure. This is a planar structure, CONH. This is nitrogen is sp2 hybridized. This is a planar structure. This is also another plane here, and this is sp3. So with respect to this plane, this carbon, these two planes have different angle. One angle is called theta, and another angle is called psi. This is designated. So in a polypeptide chain, with respect to this sp3 carbon, every alternate sp3 carbon, these two planes are there, planar structures are there, CO and NH. So these two planes have different angle, and this will changes with protein to protein, and have different. And this first time observed by Indian scientist. Name of that scientist is Ramachandran. So these angles are called Ramachandran angle, right? Ramachandran angle. So the angle with respect to the sp3 hybridized carbon to the adjacent planes is called Ramachandran angle. See which property will determine that protein will fold in alpha helix or in beta plated structure. The property decide this R. If this R is bulky, if R this is bulky, then this will go to the beta plated structure, and if this R is relatively small, then it will go to the alpha helical structure, right? Now see the tertiary structure. Third structure is tertiary structure. Tertiary structure. So this tertiary structure of this proteins is the 3D structure of 3D structure. Folding of backbone means these backbones are not so straight, they were folded in a definite manner. So tertiary structure tells about the folding of backbone, folding of backbone, and conformation in which the energy is minimum, energy is minimum, right? And have hydrogen bonding on, it is default, disulfide bonding, disulfide sulfide bonding, and hydrophobic and hydrophilic interactions. Hydrophobic and hydrophilic, right? And electrostatic, hydrophobic and electrostatic interactions, hydrophobic and electrostatic. all interactions are there, right? So this is the structure of this is tertiary structure is something like this is a particular type of folding of protein, right? So this is the 3D structure. Now come to the next structure. All these hydrogen bonding and interactions all are there. See, that is not protein is not like a straight chain, right? So this is a folded, many folds are there. So this is the 3D structure. Now quaternary structure. Don't try to make this. I mean, you can make it your own way, right? Now quaternary structure. Quaternary structure. See, quaternary structure basically this will involve the folding of different units. Suppose that one chain is there, one polypeptide chain is large chain is there, another chain is there, and both were folded in a specific manner. So this this is the combination of different subunits. So quaternary structure is the combination of different units, combination of different subunits, right? So suppose that one unit is folded like this is unit A, and another subunit is also mixed and folded, this is subunit B, right? So A B unit, and this is A unit, and all the interactions which are present in the tertiary structure all are present here, right? So with this your this biomolecules, now it is over, right?